Hello everybody, we are dealing with a very interesting problem, a paragraph from 2016 JEE Advanced. So let's get started with the problem. The problem is stating, consider an evacuated cylindrical chamber of height h having rigid conducting plates at the ends and an insulating curved surface as shown in the figure. A number of spherical balls made of a light weight and soft material and coated with a conducting material are placed on the bottom plate. The balls have a radius r which is less than h. Now a high voltage source is connected across the conducting plates such that the bottom plate is at plus V0 and the top plate is at minus V0. Due to their conducting surface, the balls will get charged, will become equipotential with the plate and are repelled by it. The balls will eventually collide with the top plate where the coefficient of restitution can be taken to be 0 due to the soft nature of the material of the balls. The electric field in the chamber can be considered to be that of a parallel plate capacitor. Assume that there are no collisions between the balls and the interaction between them is negligible. Ignore gravity. So these are the bunch of information that is given to us, and believe me, each information provided in this paragraph is of utmost importance. So the first thing that we are given is that we have a cylindrical chamber of height h which is evacuated. It is having conducting plates and then a large number of spherical balls are made of light weight and soft material. So we are considering this number to be capital N, where capital N is the number of balls that we have, and the radius r is very small compared to h. So we are not considering the balls which are very large, that it will fill the large volume space and will restrict the movement of the other balls. So r is less than small h, where h is height of the cylindrical chamber which we have, and a high voltage is applied such that the bottom plate is at plus V0 and the top plate is at minus V0. Now due to the conducting surface, the balls will get charged, will become equipotential with the plate. This word is very important. It will become equipotential with the plate and are repelled by it. The ball will eventually collide with the top plate where the coefficient of restitution can be taken to be 0. Again, this information is very useful. Coefficient of restitution taken to be 0. If the electric field in the chamber is considered to be that of a parallel plate capacitor, we need to answer the following questions. So let's get started. The first problem is asking us which of the following statements are correct, and it is discussing about the nature of the ball's motion. And the next one is talking about the average current in the steady state registered by the ammeter in the circuit. So let's get started with this problem. So for that I am drawing a label diagram back again for our understanding. So this is the diagram which we have. Now at this surface we have a large number of spherical conducting balls which will become equipotential with the plate as mentioned in the paragraph. So let us consider that capital N be the number of conducting balls which we have, and this one is at plus V0 and this is minus V0. So we can say that potential difference between the plates and potential difference between the plates is equal to 2 V0. They are separated by a height h, so therefore electric field between the plates can be calculated as 2 V0 d or h following the relation. So following the relation that VA minus VB is equal to integral E dot h, so we will get 2 V0 by h. So potential difference is equal to E into h. So we have electric field value as 2 V0 by h. And now if we say that each spherical ball acquires a charge q, charge acquired by each ball, so the first thing that we say is that since the balls are becoming equipotential with the plate, So V naught must be equal to KQ by R, and as there is no interaction between the two balls, they are not interacting with each other, from here we can calculate the charge Q on each ball as V naught R by K, and this is going to serve as the second equation which we have. The first one is this, the value of electric field. The second one is the value of charge which we obtain. And now if we write the force equation, so force equation will be F equal to QE, which this charge will experience, and hence the value will become V naught R by H times electric field, that is 2 V naught by H. So V naught R by K, and then we have 2 V naught by H. So we obtain 2 V naught square R by KH. So this is the value of force which it experiences, and this we are terming as equation number 3. So over here, if we discuss the motion of the charge ball, so due to this force, the repulsion will be created, and the spherical balls will be forced to move towards the other plate which is negatively charged. They will reach here and they are undergoing a perfectly inelastic collision, that is coefficient of restitution over here is mentioned to be 0. So as a result of which they will stick here, and then they will become equipotential with this plate. So if they will become equipotential with this plate, then they will start their onward journey. So over here, if it is acquiring a charge Q, then this will acquire a charge minus Q over here, because it will be charged by a voltage of minus V naught, and then it will start its return journey from here, will bounce back to the bottom plate, and then the motion will repeat itself over and over again. The time duration between this discharging and charging is not mentioned over here if we look at it, and the force is also not proportional to displacement. So over here, if we say which of the following statements are correct, so the ball will stick to the top plate and remain there is incorrect. The ball will bounce back to the bottom plate carrying the same charge they went up with. The ball will bounce back to the bottom plate carrying the opposite charge they went up with. So this one is correct. It will not bounce back with the same charge, but will come up with the opposite charge they went up with. And this one is stating that the ball will execute simple harmonic motion. This is also incorrect. And the force is a constant. Acceleration value is constant. So we obtained a constant value of acceleration, F equal to QE. The force is constant. So if we obtain the value for acceleration, it is not proportional to x. So we can say that the value of acceleration which we obtain is a 2 V naught square R by MKH. So over here there is no proportional to displacement relation which we have from the mean position. So we can say that it is not executing SHM, and hence alternative C is correct for this particular problem. Now over here the next part is asking the average current in the steady state registered by the ammeter in the circuit. So now to calculate the charge flown, so we can say that after a while it will become a continuous process, and the average current can be considered as charge flown divided by time taken. So over here we can say that the charge on each ball is Q, which we acquired as V naught R by K, and we are considering that n number of conducting balls are there. So if we say that n number of conducting balls are flowing, or a small n number, then we say that small n number of conducting balls are flowing, then it will become a n times Q, that is V naught R by K. Although this number n is not mentioned in the problem, neither it is asked in the solution aspect. So we need to give a value of current in terms of voltage V naught. And now we have time taken parameter. So we are looking for the time taken parameter. So divided by time which it will take. So if we say that it starts from initial velocity 0, because after striking the plate it is acquiring a velocity 0, getting charged and then moving towards another plate. acceleration value as 2 v naught square r by mkh, and the displacement between the two plate is equal to h, and we are looking for a time to calculate. So we can say that s equals ut0 half a t square. So over here, if we are looking for time calculation t, so we can say that t is equal to, so we will have mkh square by v naught square r. So up there we will have h, and over here we will have v naught. So this is the time which it will take, and hence if we substitute this value in the current equation or the average current equation which we have, so I average will take the form v naught r by k, and then divide by this time, so we will get v naught by h root over r by mk. So from here it is clear that I average is proportional to v naught square, as in the denominator we have two v naught terms, so it is proportional to v naught square, which is established from this particular relation which we have, that I average is proportional to v naught square. So if we go back to the problem to check the options, so it is 0 incorrect, proportional to v naught incorrect, proportional to v naught square correct, so it is matching with alternative D, proportional to root v naught incorrect. So this was the paragraph that turned up in Advanced 2016, which we have solved, and it uses basic concepts of electrostats, potential, and something little bit about collision aspect. So this is a beautiful problem which we have covered. So first answer is C, the second one is D. Looking forward to see more, then continue to please like, share and subscribe the channel. Take care everybody.